Okay, my micro's on. Hello, this afternoon. We today talk about a very interesting topic in product line engineering. We're talking about the last phase mainly, which is the SOP. And we have a situation which we call integration hell. And the panelists today are all partners of the digital.auto initiative triggered by Bosch. And we are all partnering in a solution approach, which we call SDV Forge. And this is what we will discuss today. There are many aspects to this. We will try to address some of them. I'm looking forward to discuss this with Stefan from HPE, Per Sigurdson from RemotiveLabs, and with Bernhard Jahnke from Bosch, and with Harald Petschnik from AVL. Okay, let's start. We have one approach, and this you will figure out over the time, that we try to develop an executable vehicle, and we will elaborate on the shift which comes with that. And I would like to have a discussion, and please feel free to respond to each other if you want. Bernd, I'd love to start with you. Integration hell means that we have a situation during the last 12 to 6 months prior to an SOP where we have integration situation and a late testability, which is the root cause for this. Where is this coming from? Why is this so present in automotive engineering projects?
Yes, Svante, you're very right. So this is a common phenomenon. So why is that? Actually, integration is a multidimensional issue. We have technical dependencies that come together. We have organizational dependencies that come together. And all of this needs to happen basically in one point in time. And the lack of ability basically to bring all these dimensions together in a sequence in a much earlier phase already basically leads to the fact that all the bugs, the faults, the inconsistencies only come to experience at a very late time.
Okay, and what would you, you're pointing out at an earlier stage, what would be kind of an approach? Perhaps Per, you could elaborate on this. What could we do in an early stage of a project to avoid this late disaster?
For me, it's about creating a playing field where things come together, where teams can work in parallel. Because currently teams work in their own pitches. The IVI team on their pitch, the body domain on their pitch, and then suppliers somewhere else. And it is first when hardware comes together that you have the entire thing. And moving things left, virtualizing, having vehicle as code, creates this playing field because everyone wants to work with the same artifacts, the same requirements, and across everything. Because when you're creating this playing field, then the things that you want to achieve emerges, like continuous early integration, like AI enablement. And left shifting is not just a slogan, it emerges automatically. But you need to get the foundation right, like vehicle as code, infrastructure, vehicle as code, and single source of truth, virtualization. We also talk a lot about left shifting communication, using the correct signals already in the virtual environment, smoking out a lot of the...
And talking a little bit more practical, what would be we have the scenario that all the parties integrate with each other over time.
Yes.
So what's the change then?
The change is that everyone is using, is on the same playing field. This is not an abstract playing field. It is that they're using the same definitions for the topology, for the EE architecture, for the bus definitions, and functionality at an early stage where hardware isn't available yet.
Yeah, I think we dive deeper into this specific topic in a second. Harald, What has data management with all of this to do? When do we have to take care of data management in this process? Along a car vehicle development project, we're talking about, like, at least in our world, about 4 or 5 years. So where is this data management happening?
I think data management is really important. It needs to go through the complete process because it starts very early, let's say in the specification phase, but later on it gets enriched over the complete development life cycle of the vehicle. And when it's especially coming to a 360-degree, I would say, mock-up or virtualized vehicle, we also need to consider 2 elements. The one is code, which represents the function of an electric control unit, for example. And the other one is the calibration data, because calibration data at the end says how the vehicle or the elements, the components are really behaving on the street in different conditions, in different environments, for different markets and so on. So we need also to get things executable also in the virtual world. We need to think about calibration data management as well throughout the complete life cycle, because it starts at the end, it develops during the process, and it gets more and more important in the in-use phase of the vehicle, because we have to think about regular software updates, if there are critical incidents, cybersecurity, safety, and we need also to change code and parameter sets throughout the complete life cycle. And those data, especially also calibration, but all the data needs to be at the end traceable and consistent.
Thank you. One question, is there a different nature of calibration data at a late stage and an early stage?
Yes and no. Data is changing continuously, also during the development and also during the in-use phase. What's especially with the software-defined vehicle and also the regulation that comes up, Regulation 155, 156, it maintains continuous maintenance of software and continuous changing software. And it's a new phase, I would say, or an extended phase, because in the past we developed towards SOP and did some minor developments behind, but now it's a continuous development.
Yeah, okay. Stefan, to your question concerning the infrastructure and the platform, how to address this topic. We were talking a lot about this, and how can we make this executable vehicle, which was like targeted earlier, how could we run this? What's required for this, especially in an OEM automotive context?
Yeah, first of all, I think the point what you made, traceability, is an important part. Therefore, it's for me not so much about infrastructure. I think, yes, it needs very good infrastructure designed to the specific use case. What do you want to realize? Is it a car project? Is it components? But the most important part for me is it's a platform approach. So like with a car, you have the platform approach. You have to think, what type of data do we need? What is how I'm able to manage my data lifecycle? How do I tag my data with metadata to say, okay, in which phase I have these data? Are these measured data, estimated data, whatever? What is the trust level of the data, and manage this over the lifecycle? And the second layer on top would be also for the AI part. So if you're working with AI to work on these data, then you would need the same as a platform thought on your AI models. So AI lifecycle, so the model lifecycle, also trace with which data, with which models, at which time, in which environment, you have evaluated or designed specific parts.
Okay, I mean, this is another interesting point. We had a discussion earlier about this managed source of truth, like we called it. And perhaps we come back to this in a second as well. Per, about like to make what you said a little bit more like tangible. How would you imagine could, like, for example, testability change from the view of a developer or test department verification when you combine KAIZENICS and RemotiveLabs approach to produce an early stage, from day one, an early stage vehicle, which is actually virtualization of the whole car, including the functionality? What would that change?
Well, it will change that you could find you will always find surprises, but you'll find the surprises at an early stage when they're easy and cheap to fix. Because having a executable vehicle at an early stage means that you can do system-wide testing, and it's also about accessibility, because hardware rigs are scarce and they arrive late. So it's not just moving it to an earlier stage and giving access to it. It is also about the scalability and giving access to more teams, so everyone can have their own virtual executable vehicle. So it is really about. I think it's a little bit overused, this left shifting, but it is this, that you can run tests that weren't possible to run before at an early stage, without having to mock and do this crazy simulation that is not so far from the real thing. So it is getting the real vehicle as good fidelity as you can get as early as possible.
Yeah. Is there an estimate how many of the late bugs, we all know late bugs are expensive bugs, how many of the late bugs can be found earlier with this approach? Or where's the threshold to what can't I test with this kind of vehicle?
Yes, so we focus a lot on the functional aspects, and some of the non-functional aspects you might need high fidelity virtualized hardware or even the real hardware. So you can't replace everything. You will still need hardware rigs, and you will still need vehicle in the loop. But we have customers saying that 90% of our problems today are functional, that can be found in virtual environments. It is based on integration problems, on misunderstandings, and not being able to run things together. So we don't have a lot of measurements on this, but our customers saying 90% can be found at an earlier stage.
I mean, this is quite an impressive number, considering that OEMs today only focus on like the real hardware delivery, then have like virtualization approaches which only cover localized solutions, like system development, etc. But that this whole space of the early phase is completely uncovered.
Yeah, but I think that comes back a little bit to that. Most legacy OEMs have been working hardware-centric, so there's no real concept of doing things there. And tooling has also been missing. And now we're seeing tooling coming from the software industry coming into automotive. So
yeah.
The time is now.
Yeah. Ich unterstreiche das. The aspect of this complexity in the vehicle which drives the problems, Ben, perhaps you could like tell us a little bit about what's actually the root cause of this complexity, where does this come from? Because people tend to say, well, yeah, a few ECUs, few functions, few requirements, go for it. But this seems to be not the reality. So how is this reference model of a car, how does this like look like?
Yeah, so as mentioned initially, there are so many technical aspects that relate to each other. Actually, it's functionality that may have an impact on the durability of a mechanical component. It's maybe a certain, let's say, cybersecurity protocol to be executed which has an impact on basically the latency, the run-through time of a signal, which decreases your performance. There may be safety implications, basically, that require to go a certain path through the architecture, etc. So all those dependencies in the end lead to the problem that we face when integrating. Now the thing is, and I think that's the big opportunity with going towards SDV and also actually making use of AI in the development process, is that we can shift the focus on the level of meaning. the level of meaning is basically where we understand how the things relate to each other. And why is that possible? If we manage our data in the right way, if we basically lift the topics into, for example, ontologies, which describe the general concept of how things work, we kind of get out of the mess of different tools, tool chains, fragmented data, which cannot be exchanged. So suddenly, with the use of that, basically we can relate maybe something that has been developed in a very old-fashioned way in a PowerPoint slide. We can relate this maybe with a SysML model or with a safety concept. With the use of AI, because AI allows us actually to tackle the fuzziness of the work that has been, or how we have been developing so far. Now, you were asking about the reference model. Well, still we need to have the idea of the concept of the car. If we have nothing to relate to, nothing to project to, actually we are lost kind of in the void. So this is actually why we are so much also focusing in providing in a systematic way the general idea of a car in the items that it has, the objects, their relations, but also the concrete content, features, how they are broken down in functional chains, the logical signals which are needed in order to communicate across the cause-effect chain in a traceable way, and use this as a backbone, as a relation of how then maybe on top of that agents can interact and so on, and in the end also be the foundation to create trust. Yesterday we heard a lot about how can trust in an agentic world be leveraged, and actually this is our perspective also of the contribution of a company like Bosch, to bring this foundation against which trust can be created in the tool chains, in the ecosystems, as you're working on with KAIZENICS, and we're jointly working on in basically the digital.auto community.
I mean, this is an interesting point. One has to point it out that the data structures and silos at the OEMs are really, they're disjunct, disconnected, heterogeneous. They're not without conflicts. They're redundant. It's not it's kind of a nightmare, one has to say. And obviously, even with AI, we have the same topic. AI is not solving this like this. We have to come to the place where we have an ontology for the whole thing. And this is a process. And this reference model could be one of the game-changing aspects in order to enable the AI to really, with the context, harvest this data from the OEM. One point I would like to pick out a little bit concerning the variant management. You briefly said this, that our 360-degree vehicle, which we can have from day one, we can produce this for every variant which is thinkable of. Well, we're talking now about billions of variants. Usually they're broken down to some nameplate variants. So we have then, and for each car, let's say, 10, 20, 30, 50, sometimes 50,000 variants. But these can be generated in a 360-degree vehicle. How does this relate to AVL's data management? This is one of your focus topics, I guess.
That's right, yeah. I think if it comes then to variant management, I think the concept gets really, really powerful, because you have, for example, you have one vehicle model, which is developed in series variants, for example, for different markets, US, China, for different regulations, for different behavior, because you want to approach different target segments and consumers. So one code gets spread up in a lot of code or a lot of variants, and these variants often gonna happen with different data sets at the end. So there's one code with different data sets calibrated. There's a lot of work behind to calibrate such different variants in, let's say, also hardware-oriented environments, testing environments. And this, I see, there's a strong shift now, and also a mental shift on the OEM side to go more into virtual environments, to find the right calibration data for different targets. Why? Because you have you are faster at the end, so the time to market, of course, and there's a lot of compute power available, for example, for virtual environments to get real testing coverage at the end. If you have huge testing coverage in virtual environments, you know which tests you want to replace in real environments. So at the end, of course, there's a cost savings because virtual environments are very costly at the end. If you think about prototype vehicles and testing it on the street. So this is really important at the end on the variant management side, and I think the variant coverage is a high, I would say, driving force into the virtual world.
Well, I guess because in the real world, the variant management is like hard to test if you consider all variants. One question to you, Stefan, a little bit addressing to what Bernd said, concerning the data management and the trust level of data. We are talking here about confidential data at the OEM. How could we realize corporations in a private cloud environment, and how do we manage trust level of data elements, objects?
Yeah, so I think what you already mentioned is the trust level within your organization is extremely high. Now you're collaborating as an OEM with a lot of suppliers, and these are IPR relevant data. So for everyone who is contributing to a car project, it's highly relevant data. In early stage, you are contributing. Therefore, this platform, data-centric architecture, name it, idea is about you have to have these managed via metadata, saying, okay, this is a propriety of AVL, of Bosch, whatever. And these data can be shared or can't be shared. Which part of the data can be shared? Is it only the interface data? This is a point which is it's highly relevant. Therefore, for me, would be always it's encryption first. Everything is protected to be seen by anyone else until the data owner, data provider is saying, okay, this part of data I'm allowing in the following context to be visible within this given car project, as an example. Which is then going into next level. Maybe you mentioned before that you have in the car project, you have this 150% view of the car with a model for the Asian market, for the US market, for the German market, and you might want to collaborate within your organization with China, with US, with Germany, and already within your organization, you might have restrictions which type of data are visible. From software development in China, is it visible in US or the other way around? And these things is a point where a data-centric approach is helpful, and this the platform approach with the metadata. And I would, as last point, I wouldn't think of, when I'm talking about a data-centric approach, it's not just a new point of presence. It's not just the super cloud by what I'm building, but it's an ecosystem and mesh of data platforms working together in a data mesh, like we have in the data, there's a Catena X idea of collaborating and using these metadata to manage the right access for the right project in the right content.
Okay.
Maybe I would like to emphasize and comment on that. So from my perspective, really, that is a very big change that we look in. I mean, the typical business relations, they are breaking up, like providing an RFQ, answering the RFQ, agreeing on milestones, delivering at a milestone. Instead, like the technology, the foundation that you address allows, in the end, the full ecosystem of OEMs, suppliers, partners to move jointly. And if that can't be achieved, basically this idea of continuously integrating, of continuously finding the bugs will never happen. So therefore, I think we really have to understand that this transformation of shift left goes through all the facets of collaboration and technology stack more or less at the same time. And this joint movement forward is really kind of the key.
I would like to integrate this as like one part of the summary. I liked it. Yeah, we need to come to an end. I actually wanted to jump a little bit on the topic of SDV and pre and post SOP, but we don't make it anymore, unfortunately. So this is like a early invitation to our booth to continue discussing this with our partners. Very important, I think, mostly you already said it. I think one of the SDV Forge, one of the main core issues is that we need to build an early testable vehicle. Because this is the object which is evolving in time and which like connects people and which will be the real truth of things. It's not the paper anymore. We don't need any more AI to produce another requirement like a catalog. We need a living object, and this is one of the core theses behind this. Yeah? And this is what we are all working on. To complete this talk, would you, all of you, give us a little statement in the direction of OEMs? What should they change during the next 12 months? Just like one core thing to change. Stefan.
So data first and working in a federated environment. So protecting the IPRs of every part in this ecosystem.
I want to say maybe I agree, and I will also want to say there needs to be a mindset shift in the industry as well, because you should compete with speed, and of course things need to be confidential and kept up. But I think it's about speed. But then what I would say more is that yes, start somewhere. Because everyone wants this virtual vehicle, but then it's this big elephant. And one way to slice it is to actually put the virtual vehicle, parts of it, before the hardware. We see a lot of customers doing this in parallel. They have the hardware track, and then they do the virtual parts on the side. And then it's just a nuisance, and then it's a catch-up. So hardware should catch up with software and not the other way around.
Yeah, my statement would be put the meaning in front, focus on actually what the product relevant meaning is, instead of like optimizing, investing into tool constraints, into definition discussions, etc. Like the meaning is what counts, and I think that's the way we are approaching here.
Yeah. My statement is, if you think about software-defined vehicle, think about software first, because software is driving at the end the function. So we need to rethink the development process. We need to break up the silos. I think technology is there and partially proven. Now it's really to change processes and to start with the SDV, hopefully in another approach. Yeah. So in a new approach.
Yeah, I think we heard this more often, that the SDV approach includes lots of truths already, but the OEM structures and approaches need to comply with that. Yeah? So thank you very much. I would like to conclude with one remark. We've got produced a white paper where we released the version 1 out of 4 last week. So if you would like to know more about this topic, like I said, you're welcome on our booth. We are all around. And secondly, this white paper is to download, and just ask me. I'm going to forward this to you. Thank you very much. Thank you very much for participating and attending.
Thank you.